This is a primer for how to set up the basic perspective grids we'll be looking at in our Drawing the Basics class. Due to limited time, most of our class time will focus on two-point perspective, which I believe to be most useful and which I also believe most accurately represents not how we actually see optically, but rather how we perceive things when measuring angles while observationally drawing as a result of our eyes and head moving and our very limited locus of vision. But first, let's look at single point perspective, which can also be useful for dramatic purposes. Remember, you can pause this video and look closely at what you are seeing. You can also back up. There will be video demonstrations following this in which I blather on incessantly about this subject while drawing. Okay, to start with, draw a horizon line on your piece of paper. Mark a single point on it. I've used an X because, well, X marks the spot. I haven't made it in the middle of the page for demonstration purposes, but I might have. Now, imagine lines radiating out of that point on the horizon line, or if you will, lines converging into it. Here they are. These lines are simply guidelines. You can make as many of them or as few of them as you wish. This is the single vanishing point for a single perspective. Everything converges and plummets into it or radiates out of it. It is the typical way in which railway tracks vector off into the distance or converge on a point on the horizon. Or it is the classic view down an elevator shaft. These two single point perspective applications are perhaps most dramatic when the vanishing point is placed in the middle of the page or horizon. However, we've got our point to one side, so I can illustrate drawing a box to one side of the more direct trajectories into the vanishing point. Here I have drawn a box, perhaps a simple building by the railway track. All my verticals are plumb and parallel, and if you inspect the box closely, you will see that on the face of the box that is directly in front of us, the horizontal lines are completely parallel. They are not converging like the lines on the side of the box that are parallel to the railway track. Only one side of the box has linear perspective and foreshortening applied to it. The edges parallel to the railway track. And those edges of the box, if extended, vector off into the distance to converge on the horizon, like the rails themselves. The edges on the front face of the box are parallel, and the vertical box edges are also parallel and plumb. This means both these parallel edges are also parallel to the edge of the picture frame, top or side. This provides a pleasing graphic designy effect, I think. You might draw or paint the side of a building like this, as I have done before, or a view down on a table. The flattening effect and mirroring of the edge of the picture creates a designy look, all the while giving a tip of the hat to depth and linear perspective on the aspect with the converging sides. This is what I suspect is so pleasant. Relative to the drama of the elevator shaft, this is a fairly quiet effect. Here's a quick look at a parallel projection. Notice there is no convergence of the grid lines or on any of the edges on any aspect of the box. They are all parallel. And here's a nice symmetric parallel projection. I'm not an expert on the usage of parallel projections, as I'm not an architect or engineer by trade, but someone with an interest in drawing should have some curiosity about how parallel projections appear and how they can be applied. If the box drawn on this grid were 1 foot high, you will note that the back edges of the box are exactly the same height as the leading edge, as they in fact are. In a parallel isometric projection, there is no linear perspective, no foreshortening of scale as parts and wholes recede into the background. Indeed, if the box is exactly as deep and wide as it is high, say 1 foot, then all the edges should be exactly the same length in its isometric depiction. This is what is so wonderful about parallel projections. For product design of any kind, sizes are relatable with no distortion of scale due to the effects of linear perspective. In a parallel projection, it is as if we are viewing the box from an infinitely distant vantage point and zooming in on it. In linear perspective, the object, whether viewed from close up or far away, is always at a finite distance. This means the vanishing points are at a finite distance apart. However, in a parallel projection, the vanishing points are at an infinite distance apart. No matter how far left or right you go to look for them, you will never find them, because the edges of the box don't converge on the horizon at vanishing points. They are parallel. Because edges of the box don't converge on the horizon, you'll never actually find the horizon itself either. The further you push vanishing points apart in a 2-point or 3-point perspective drawing, that is, in the general direction of infinity, you increase the effect of viewing from a vantage point further away as though through a zoom lens, and the flatter the perceived object becomes. That is, the closer to appearing parallel box edges that are in fact parallel appear to be. But as far apart as you might push your vanishing points in a 2 or 3-point perspective drawing, if you measured parallel box angles, they would eventually converge on the horizon somewhere outside of the picture frame. Not so in a parallel projection. The parallel edges of the box are in fact parallel and never meet again. There is no vanishing point. There can be no horizon in this view from an infinitely distant vantage point. Now let's look at that 2-point perspective grid. 2-point perspective, for me at least, is the most useful perspective grid, and also the grid that seems to most emulate what I see when observationally drawing and measuring angles with one eye shut. You draw your horizon line. You put 2 vanishing points as far apart as you wish. Bear in mind, putting them very close together will force the perspective and distort your subject matter accordingly. You can experiment with drawing boxes with closer and more distant vanishing points on your own in class or at home. Now, from a vanishing point, I can radiate lines outward, or as you wish, converge lines inward. Here they are below the horizon. Again, be aware that these lines are just guidelines and can be as numerous as you see fit. Notice how even this simple graphic representation is giving a bit of an illusion of a surface and a sense of space. Now I add the same converging or radiating lines above the horizon in the sky. Now I'm doing the same for the vanishing point on the opposite side of the horizon line, below the horizon and above the horizon. Already there is a strange sense of geometry that alludes to a landscape or surface. Here I've drawn a box below the horizon line. In a 2-point perspective drawing, vertical lines that are plumb are drawn that way, parallel to the vertical edges of the picture frame, with no convergence above or below the subject. I can extend the box higher above the horizon, and so can you in your own experiments in class or at home. And you can see how the top edges of the box still converge toward the vanishing points. If the box is anywhere below the horizon, you will see its top. As you raise the box toward the horizon, the shape of the top of the box will condense into a slimmer and slimmer perceived shape until it is at the same level as your eyes on the horizon, at which point it will become a line, and once above the horizon, you will not see the top of the box. You could experiment with this in class or at home by noting that your eye level is in fact the horizon line. Raise a box in front of yourself at arm's length and notice how the top of the box disappears at eye level, which is your horizon line. If you lay on the floor and observe something, you lower the horizon line. If you climb a step ladder, you raise it because you are raising your eye level. The view from a step ladder is like looking down on a perspective grid from a high vantage point. Here I've drawn another box beside the original box in the bottom right-hand corner of the drawing. Notice how as a subject moves to the edge of the grid, it becomes distorted. You will notice this effect further enhanced when you force the perspective of your drawing by creating a grid with the vanishing points closer together. Here I've chucked in a few clouds. An understanding of perspective is invaluable for landscape painting if you wish to have a sense of pictorial space. The placement of these clouds very much keeps the perspective grid in mind. Cumulus clouds are bulbous and broad, but have flat bottoms. They are essentially convecting bubbles of warm air lifting off the ground like water bubbles lift off the bottom of a boiling pot. When these warm air bubbles cross a clearly defined boundary from warmer to cooler air at altitude, the water vapor in them condenses and forms a cloud. This is what makes the bottoms of cumulus clouds flat, while the warm air envelope continues to bubble up above the flat bottom into the cooler, higher layer of air. What this means is that if you were looking up above you at the bottom of a cumulus cloud, it will appear ragged and wide in shape. You will not discern the flat bottom because you are looking directly up at it. However, as clouds are perceived further in the distance and therefore closer to the horizon, their flat bottoms become more apparent. This effect should be apparent in the clouds sketched here. The bottom of the clouds on the horizon almost appear to be parallel to the horizon. When driving down the island highway and enjoying splendid views of the Salish Sea and mainland mountains, if there are clouds in the sky, look closely at how perspective plays with them. Okay, pull over and look closely. If you're driving, you really should be watching the road. I mentioned putting the vanishing points further apart. Of course, on a piece of paper, you can't go beyond this edge. Unless you use a long straight edge to extend your horizon beyond the edge of your paper, like so, on a bigger sheet of paper, or sheets of paper taped together. You can now push your vanishing points far, far apart by actually having them beyond the edges of your paper. Now, at the grid. Draw a box. You will find that the further apart you put your vanishing points, the flatter the box appears. That is, the less forced the perspective is. That is, the lines that converge to the horizon do so less dramatically and appear closer to parallel with the horizontal direction of the horizon. Suppose I draw the same or a similar box further away, closer to the horizon, in about the same spot as I placed that other box. I am therefore further away from it. My vantage point is further away and therefore closer to an infinite distance from the box. Note, if you can, how the top of this new box, the bottom edges appear to have flattened out, to have become closer to parallel with the horizon. That is, to have become closer to a parallel projection. This is the flattening effect of a zoom lens, and I'll show you some shots from a couple of films later that use this effect wonderfully. More on two-point perspective and observed perspective in general. Here's a two-point perspective grid suggestive of a view from a height of land, perhaps even in the air above Forbidden Plateau here on Vancouver Island, looking across at the mainland mountains. And here's Comox Spit, Tree Island, and Denman and Hornby Island sketched in. As well, I've sketched in the shoreline of the estuary and the valley in a wide sweeping arc from one side to the other. We are very much looking down on this estuary shoreline, and as a result, it is nowhere near parallel to the horizon. But as the shorelines get closer to the horizon, first the spit, then the islands out there, the shorelines for all intents and purposes are completely horizontal. Over on the mainland, although the shoreline is ragged and full of complexities such as fjords and inlets and islands, none of this is perceptible because it is so far away and the complexities appear parallel to the horizon. It's very much as with the top of a box that you lift to your eye level. Complexity and shape condenses into a thin line and disappears. Here's another perspective phenomenon. Imagine a box, a building if you will, out there on Goose Spit. Now, from this point of view, the mountains seem a long way away, far further than the box. Let's imagine we have a zoom lens and are going to zoom in on the house from this distant vantage point, closer, and here we are. Up very close, zoomed right in. Notice how large the mountains now seem relative to the house pictorially. The mountains loom up over the house and are an overwhelming presence. But we know this isn't the case. We know the mountains are many kilometers away on the horizon in the far distance. But we have, by zooming in, brought them closer and scaled them up relative to our house. This is the deceit of zoom photography. This is how you could create a travel brochure for Comox and make it appear as though the town almost sits in the shadow of the beautiful mainland mountains. Tourists might browse the brochure and think that their visit to Comox will put them under these mainland mountains. But when they arrive and walk the streets, they will have to look long and hard to find them. Hopefully, they won't be too disappointed. The deceit as a result of the lens is also very creative, and it is not a creative tool just for photographers. There is no reason artists, painters, and drawers can't use the many attributes of perspective to creatively and emphatically communicate visually with a perspective. Let's zoom out again momentarily. Rather than put clouds in the picture again, let's have an invasion of alien flying saucers emerging over the horizon. I've drawn the near saucers up close above us, roughly using the technique for creating ellipses. But as they get close to the horizon, their bottoms, much like the top of the boxes viewed below, that we viewed below the horizon, are getting more and more elliptical. The circle is flattening out more and more until when nearing the horizon, the circle appears just like a line, as happened with the top of the box. Now, run and hide before the aliens fire up the death rays. If you take a look at most photographs taken with a standard lens, you will notice that vertical lines are not plumb, unlike when you measure angles observationally while drawing and set back somewhat from your subject. If you were looking down at your subject in the photograph, vertical lines will converge downward to some degree to a vanishing point somewhere in the depths of the earth. If you were looking up at your subject, perhaps a box, lines will converge to a vanishing point in space. Let's take this latter scenario and create a three-point perspective, left and right vanishing points, and a third vanishing point off in space. We'll create a point between our horizon vanishing points and draw a vertical line upwards, and in this instance, we will make it the same distance as our other vanishing points are from the center point. But you can put your vanishing points wherever you like, bearing in mind that the closer they are together, the more forced the perspective will be, and the more your subject will tend to distort. Now let's quickly draw grid lines radiating out from our three vanishing points. Yet again, these are just guidelines for our drawing. There is quite a swarm of lines going on here, but if you look closely, you can see where and how to sketch out a box-like tower of sorts. The third vanishing point is quite close to the horizon, relatively speaking, so the perspective is forced somewhat, and as you look up the tower, it is dramatically foreshortened in what is called a worm's eye view. If we oriented our page differently, we could make that third vanishing point further away. Here's a grid configured likewise, and here's a box drawn on it. And here it is up close, still converging fairly dramatically, but less so. How far you put the vanishing points apart is similar to changing lenses on a camera. It is a creative choice which is allowed you if you understand the basics of perspective and the basics of drawing. Back to that original 3-point perspective grid and box-like tower. So, we've covered no vanishing points, as in parallel projections, 1 vanishing point, 2 vanishing points, and now 3 vanishing points. How about 4 vanishing points? A 4th vanishing point should provide a complete dimensionality. So here it is. And here is the box tower extended down below us with lines converging so that the converging to that 4th vanishing point. What we are seeing is a forced perspective point of view of what appears to be the central part of a tower viewed from part way up, so that we can see both down and up at the same time. There is a glitch, and you might notice this. What the heck do you do with the abrupt shift in direction at what was once the ground level and is now part way up the tower? The straight line converging geometry of 1, 2, and 3-point perspective fails to accommodate that 4th vanishing point. If we photographed a building from this point of view with a wider angle lens that forces perspective to this degree, what we would see is the vertical lines curve around like so. In fact, the wide-angle lens would be very much like looking into a mirrored orb to properly accommodate that 4th perspective point. The world would curve around and be especially distorted at the edges of our view or the orb, as at the edges of an image projected by a wide-angle lens. We can now see our top and bottom vanishing points much like the poles on a globe, and the lines projecting from each of them should curve around the globe and reconverge on the opposite vanishing point, much like longitudinal lines on a globe of the Earth do. And our left and right vanishing points are also like sideways poles, not so much like latitudinal lines on a globe of the Earth, which are parallel. These latitudinal lines converge from a vanishing point on the left or right and then curve around to reconverge on the opposite antipode-like vanishing point. This curvilinear perspective is really what a 4-point perspective requires. So there you have it, or what I've estimated to be required knowledge of perspective grids for the drawing basics. Parallel projections, 1-point or parallel perspective, 1-point perspective, 2-point perspective, 3-point perspective, and curvilinear perspective, and the grids associated with each.